Everybody, this is Ed. Today I'm gonna show you how merge sort works. Merge sort is an algorithm that allows you to sort a list efficiently. In this case, I'm going to use numbers. So unlike selection sort and insertion sort, merge sort is a recursive algorithm, which means that it calls itself in order to um, organize the data. So there are two parts to merge sort. One of the parts is called sort. So this is where we divide the list into left and right halves. You may have heard that merge sort is a divide and conquer algorithm. So essentially merge sort, this function, is the divide part, and it's going to keep calling itself here recursively until you reach the base case, which is when you have one element left. So when we reach that case, we say that's the simplest you can get and it's already sorted, so we're going to return. Alright, so you can see I have one recursive call for the left half and another one for the right half. After we have sorted the left and right halves, we are going to call this function called merge. So merge is where all of the work gets done. This merely, separates the list into, essentially it halves the list until you get the base condition. But merge is going to do the work of putting the numbers in the list in the right order. So we're going to pass the middle index, which we calculate by simply adding the beginning and the ending index and dividing by 2, and we're going to pass the start and the end. So you can see that the merge function is a bit more complicated than merge sort, and that's because we have to make sure that we put the indices in the right order. We're going to store that in a temporary array, which is going to be the same length as the end minus the start index plus 1, because we want to include all the elements. So it's probably better if I show you how this works, go through it with you in the debugger. So I'm going to click that. Alright, let me change this so we can start from the beginning. Alright, so I passed in 0 and 7. 0 is the beginning. End is, as you might recall, the length minus the 1. So we have 0, 7. 7 minus 0 is greater than 0. So that means we haven't reached our base condition and we can continue. We calculate the mid, which is 3. And we're going to only look at the left half right now. So we're going to recursively pass in the start and the middle. So that's going to be 0 to 3. We're going to keep doing that until we end up, we reach our base case, which is 0, 0. So that's when we only have one element remaining. That's going to be 8. Now you can't sort one integer because there's only one of it. So it's when we reach that base case we're going to return, and that's going to bring us back to when we had the start index as 0 and the end index as 1, and it's going to do the left half. So you can see start is 0, end is 1, and we're doing the left half, so that's going to add 1 to the middle, and we're going to look at the right side now. But that's also going to return. And this is where we really start to see how merge works. Um, as I just showed you, we don't do any work when there's only one element, but once those are done, this recursive algorithm is going to use the results, or I should say the elements between 0 and 1, and merge those together. So the base condition just allows us to return to a case where we're actually able to sort things, So right here I'm just printing out to the console what's on the left and right side. So 8 and 5. And length is going to be the ending minus the beginning plus 1. So that's going to be 2. And so we're going to initialize some variables that will help us keep track of where we want to, how we're going to find the indices that we're interested in. So the right half is going to begin at m plus 1, which is 1. And the middle is going to be 0. So we're going to keep track of where the left half begins and ends, which is from 0 to the middle, and where the right half begins and ends, which is from m plus 1 to the end, which we also passed into our merge function. Alright, so you see here, this is a new array that we pass in. So we have to, before we put our sorted elements back into the original array, we have to put it inside the temporary array. Otherwise, it's going to be difficult to, we're going to be like, replacing numbers in the original array, and that might make it difficult to sort. Alright, so right here we are iterating through the left and right halves. So S is going to be the start. So remember, it's 0. So let me open this up for you. Alright, so remember, S is 0 and R is 1. So this is where they begin, the left and right halves respectively. Okay, so we look here, 0 is 8, at 1 it's 5. We're going to compare those indices to see which one's greater. The 8 is obviously not less than 5, so it's going to go into this else statement right here, and we're going to put these in the right order. Alright, so you can see we exited the while loop because once we reach the end of one of the halves, that tells our program that we're done. We're done, sorting both sides, and we're left with one half that still has elements in it. So because we're starting from the simplest condition, we know that these halves are in the right order, and when we've reached the end of one, we can simply insert the rest from the other half. So that's what we're doing right here. S still has a variable in it, a value in it, which is 8, and 5, we already said 5 is less than 8, so we can put 8 back in as the second element in our temporary array. Okay, and right here, this is where we copy the elements from the temporary array back into the array. Right here I'm just printing out to the console the results after the merge. And so we're going to go back. So since we just finished one half of it, we're going to go back to our merge sort algorithm, and it's going to take us back to the previous branch, which is which had it start at 0 and end at 1. So we should be going back here because that's the right branch. Alright, so remember before we were going from 0 to 1 in the left branch? Well, now we're going to do the right branch. So we're going to do from 1 to 3. Alright, and that's going to call itself again, and we're going to do the left half of that. That's going to return. We're going to do the right half of that. That's going to also return. And now we're going to merge the right half. Oops. So you see that it's putting these in the right order, even though it's already in the right order. It still has to compare them. Alright, and we return to the function. It's going to return because we reached the end of the left and right branches. So now it's going to go up one more level. It's going to use the results from the left and right branches, and it's going to merge the 4 elements that we just looked through. So from 0 to 3, so our array has already been changed. So now you see that the left half right here and the right half are in the right order. Now we're going to repeat this merge, which is going to look at one array at a time, compare compare the indices of each array in order, and then put that into the temporary array. So we should get 2, 5, 7, 8. Okay, let's get the new temp right here. Alright, and once we put everything in temporary array, we are going to copy it over from the temporary to the main array. And we got a bunch of numbers here that we are going to do the right half. So remember, when we pass this original array into here, the start was 0 and the end was 7. And then we were looking at the right half, which starts at 0 and ends at 3. Well, now we're going to go into the right merge sort. We're going to sort the right half with the merge sort. So that's going to look at 4 to 7. So basically repeating the same call, that's going to divide this into simpler problems and then sort it once it reaches the base case. Okay. So let's see, we go to 4 and 7, and now it's going to look at the left and right halves, chop it up into smaller bits, so the computer is able to make this a simple task. Okay. Now it's going to do the right half of the right half. So now it's organizing the two elements of the right half in the right half. And its recursion is sort of like very tricky because you really have to be able to go deeper into the function and not forget about. You have to remember the previous steps in order to understand the next ones. Okay, I might as well just finish up here because you guys probably get the gist of it. Okay. All right, so let's open up the console. So you see how many steps it took to get from the beginning to the end? So we started with the left of the left of the left, which was just one. So you see every time merge sort is going to have the number of elements. So that's why in all there is a log 2 levels. We started with 8 elements. Log 2 of 8 is 3. So we're going to make so this tree, which so each level of the tree is kind of like a recursive call. It's three deep. So we're going to make 3 recursive calls for each path from the root to the leaf. So we get right 8, 5. So this is our first one. The first time we call merge, put those in the right order. And let me show you what the original one looked like, the unordered one. So 8, 5, we put 5 first, then 8. Do the same thing with the right. This part, 2, 7, 5, 8, 2, 7. Now we go up, we go back up, we return from the previous recursive call, and we go up a level. So now we're gonna compare sets of 2, 5, 8, and 2, 7. It does that. 2, 5, 7, 8. It's going to put that back inside, so it's going to look like 2, 5, 7, 8 now. All right, and now we look at the left and right. Well, we go deep, 3 deep into the right half right here. So we're going to eventually get the leftmost of that subtree is 9, and the adjacent one is 3. I'll sort those. Going to do the same thing with the other half. And we will keep on organizing it until you have organized this side. So it's going to look like 2, 3, 9, 15. All right, and now you're able to compare the sets of 4 and organize it into the set of 8, which is the same length as your original array. So that's when your program will return, and there will be no other merge functions that are pending. So your merge sort will exit and go back to main and print out everything. All right. Yeah, sorry for making this so long, but congratulations if you made it to the end, and yeah, let me know what you think. Okay, all right, have fun. Don't get discouraged. This is was pretty difficult for me. Oops, how do we get out of here? I hate this thing. What is this? What the?